some prepared remarks for us?
Yes.
All right.
Really good to
Please.
go?
Yes.
All right.
I'm ready.
Hi, we're the Green Girls, Team 7190, a 9th-year first and a 6th-year FTC team from Eagan, Minnesota. This season, we have all embraced every aspect of the challenge, including designing, building, programming, and all of our various community outreach activities. My name is Grace Hansen.
My name is Claire Myers.
I'm Erica Broker.
I'm Rebecca Lundquist.
I'm Zoe Berg.
I'm Shelley Franklin.
And I'm Chris Leverett.
Before we begin, as you may know, this is our last Minnesota FTC Judges presentation because we are all seniors. So, before we jump into the presentation, we'd like to take the time to thank you, the judges, for all of these amazing opportunities that you've given us over the past 6 years. We've incorporated everything we've learned from this challenge and FTC into this robot, this engineering notebook, and this team. So, from all of us to all of you, thank you so much.
Thank you.
Green Girls Team 7190 is committed to demonstrating the goals of the FIRST organization and strives to transition from a successful FTC team to college-level engineers.
Our agile engineering process guides us through our life cycles as we identify our goals, track our problems, and come up with innovative solutions.
Our game strategy and robot design complement each other, and our effective communication skills allow us to adjust to the strengths of our alliance during each match.
By implementing many innovative designs, we built a unique robot that solves the rover ruckus challenges in a variety of effective and inspiring ways.
Our community outreach involves connecting with both our local and international community, as well as other FTC teams and the professional STEM world, so that we can learn from STEM professionals, share what we learn with other FTC teams, and also provide impactful STEM learning opportunities for kids in our community.
We are dedicated to teamwork and collaboration with each other as well as fellow FTC teams, because our impact as a team is greater than our impact as individuals. We've all come to realize that FTC isn't about where it takes you, it's about what it makes you. As women in the STEM world, we serve as role models for young girls by being global ambassadors for FIRST. We're holding STEM clubs in our local area for underserved children.
First, we're excited to talk to you today about our community outreach. We have 3 subsections to our outreach. The first is Green Girls Give. This is where we go out in the community and give back. This past season, we have participated in and led 77 outreach events, totaling over 1,100 hours of community service.
Before we tell you more about our outreach, I would like to tell you about a word that's really important to our team, and that is our trademark word, diversity. Diversity combines giving and diversity. What that means to us is that we especially like to reach out to kids who don't see STEM first in their daily lives.
We host bi-weekly STEM camps at both the Pacer Center for Children with Disabilities and with the Dakota County Foster Care Program. At these camps, we teach our custom STEM curriculum, with each camp focusing on a different aspect of STEM. We also are teaching them about FIRST. Here is a booklet filled with the curriculum that we have prepared.
Our STEM Foundation is an integral part of our legacy as we continue with our final season of FTC. Our 501c3, the Green Girls STEM Foundation, is aimed towards encouraging and increasing diversity in STEM, and especially in FIRST. This season, we have raised $15,000 for various grants and scholarships for this purpose, such as 5 $1,000 scholarships that are available to high school seniors through the FIRST website.
Because this is our last season, we want to pass down all that we've learned over our 6 years as an FTC team. This season, we've been in contact with over 20 FTC teams, such as rookie teams like Clockwork, and have taught them about all aspects of FTC. At the end of the season, we'll be passing on our community outreach programs to teams such as the Crushbots and Thunder Penguins, and we'll also be donating all of our parts and field elements to existing teams. We're also in the process of compiling all of our knowledge into video resources that teams will be able to use after we graduate.
This season, we wanted to embrace the FIRST values of equity, diversity, and inclusion. And to do this, we have partnered with organizations such as Queer Science. We connected with Queer Science, which is an organization that is focused on getting LGBTQ+ youth into STEM. On December 1st, we taught a robotics building session at the Queer Science Day event. We are currently in the process of donating $2,000 to them to help their organization grow and prosper.
This past season, we met with Crystal Valentine, a member of the United Nations and an engineer at Accenture in Sweden, to work on a project called Gold Tracers. Through Gold Tracers, we have created a plastic extruder, which takes old 3D printed parts and recycles them into new filament. During the tournament this weekend, we'll be collecting old and broken parts from other Minnesota FTC teams and using them with this extruder. If you'd like to come see the extruder, it'll be in our pit all weekend. The second section of our community outreach is called Green Girls Grow. This is where we go out in the community and connect with STEM professionals.
Our team is working with Eagan FRC Team 2220 and multiple other FTC teams in order to promote a culture of safety in FTC. We met with UL, a safety company, in order to go over our collaborative manual. And this weekend, we'll be going around and talking to teams about our safety initiative and trying to get them to join it.
This season, our team reached out to and scheduled time with over 70 STEM professionals. I'd love to tell you about them all, and they'll tell you about my two favorites, Entropic Engineering and Minnesota Waterjet. Both of these companies helped us bring our 3D design to life through manufacturing. Here are some failed parts from when we went to Entropic Engineering and we learned more about the limitations of CNC machining. I'd love to show you a visual of all the professionals we have met with this season when you come visit us back in our pit.
In January, we hosted a design panel expo. We've hosted design panels in the past, where some professionals come in and give needed advice, but this year we wanted to make it global. We live streamed the event on our social media and reached hundreds of people.
Along with preparing for this tournament, we've simultaneously been preparing for the United Nations International Day for Women and Girls in Science. We'll be leaving on Sunday for the two-day workshop and event in New York. While we're there, we'll be presenting on 5 different topics, including FIRST, Goal Chasers, Queer Science, as well as our custom STEM curriculum. We've also invited Egan FRC Team 2220, as well as a member of the Thunder Penguins to join us.
Our final subsection of community outreach is called Green Girls Gather, where we get together and collaborate with other FTC teams.
This past fall, our team hosted an FTC team social. The teams could get together, have fun, and get to know each other outside the competition atmosphere. These socials promote collaboration and create a sense of community amongst local teams. We are also planning to have another social on February 17th for girls in FTC.
Next, we'd love to talk to you about our engineering process. As you can see, we have 2 parts to our engineering notebook. The first is typed. This includes our team section, business and sustainability plan, 501c3 information, and outreach activities. The second part of our notebook is the engineering section. We have chosen to handwrite this section for the past 3 years because we feel that it reflects more of what engineers use in the real world. This format's also great because we can take it out into the shop with us and refer to it on a daily basis.
Through connection with STEM professionals, we have learned that it is important to begin by identifying our constraints. We then turn these into tasks and stories we put on our backlog and pulled forward into our bi-weekly scripts through our agile engineering process.
Our many brainstorming sessions are documented throughout our notebook as we continue to think creatively throughout the season. Another aspect of our brainstorming is through research and review of past seasons.
We use Creo Parametric along with top-down design with custom constraints to both create and test our robot virtually prior to building it. This allows us to create custom parts that are tailored towards our game strategy, designed for manufacturing, and saves us time and money. We cannot wait to show you the CAD in its true 3D form when you come visit us back in our pit.
Prototyping is an essential part of the building process. It allows us to work out our designs physically out of cheaper materials before we commit to specific design. One of the ways we've done this numerous times this season is through our multiple iterations of our harvester using different designs and materials.
We use CAD to design and test our robot, as well as using additive and subtractive manufacturing to create a truly custom and robust design. You can see here in our engineering notebook a step-by-step process in CAD of how to construct our entire robot.
We then test our robot utilizing our critical testing plan, which allows us to evaluate risk and find areas that need to be improved upon, as you can see here. After we test, we then repeat the life cycles in order to improve our robot and produce a release before each competition. As you can see, both of our life cycles are color-coded, with each step having its own unique color. Then, in our meeting notes, depending on what part of the cycle you're currently in, we use corresponding color in the titles.
This season, we spent a lot of time creating consistent teleop and autonomous programs, so we've implemented many controls, including sensors and algorithms.
We have created multiple test programs that allow us to isolate subcomponents of our robot and be able to really work out problems before we get them onto the full robot.
At the beginning of the season, we experimented with sonar sensors to see if we could use them during our autonomous to sense the wall. We found that we were getting really inaccurate readings, so instead we switched to the REV 2-meter laser distance sensor and put encoders on our drive wheels.
We use the compass sensor inside of the IMU on the robot in order to read the robot's heading or the number of degrees that we want it to turn.
In order to accurately sample the minerals, we are utilizing TensorFlow computer vision using this camera. This is a function of Vuforia image processing that allows us to differentiate between different objects that the camera sees. We use this during autonomous to differentiate between the gold and silver minerals so then we sample correctly.
To prevent the vertical hanging lift from overextending, we utilize an encoder on the vertical hanging motor, which is down here. As the lift goes up, the encoder counts to 5,000 ticks, and then it stops once it reaches that point. And when we bring it back down, the lift will not stop until it touches this touch sensor right here.
For autonomous and teleop, we utilize these LED strips
here to signal what state of the robot we are currently in. For example, during autonomous, when we sense the gold mineral, the lights light up gold, and when the arm is up and scoring, the lights are multicolored.
Our mission for our robot this season was to make it fast, easy to maintain, and be able to work well with our alliances.
For state, we really wanted to focus on consistency and reliability. Our pre- and post-match checklists ensure that our drive team and robot are ready to compete.
Our base has a sleek and modern design, formed from 2 water jet cup plates with space here for our custom-made motor mounts. You can see the design of these motor mounts here and manufactured here on the robot.
Our harvester, like the rest of the robot, is completely custom made. It uses a sweeping motion in order to collect the minerals into the harvester, where it stores prior to depositing them into the lander.
In order to reach the lander, we flip the arm and shoulder up. These gears form a 5-to-1 ratio, and they have a 1/2-inch hex bore with a 5mm axle running through it, connected to these custom designed and manufactured pillow blocks. This gives the drivers more stability when they're using the mechanism during drive time. We've also 3D designed and printed a mineral self-sorter. The gold minerals are directed to the right under this bar, and the silver minerals are directed to the left. This is also especially helpful when driving because we can use this on either side of the lander.
To hang during endgame, we use a 128-to-1 orbital gearbox on our hanging motor. We used to use a 256-to-1 orbital gearbox, but we found it was much too slow. The 128-to-1 ratio gives us the perfect balance between speed and power. We have custom designed 20 3D printed parts that you can see on our robot here today and on this board here. So examples of our 3D printed parts that we've done this year is our custom designed wire organizer, our marker named Howard, and our custom designed mineral sorter. To get all of these different iterations of the mineral sorter, we ended up using our critical testing plan to find areas of weakness in each one, and we also decided to use PETG filament for all of our critical parts due to its strength and its sturdiness.
We have about 2 minutes left.
Green Girls Team 7190 has demonstrated the goals of the first organization.
Through a detailed engineering notebook that provides step-by-step instructions on how to design and build our robot,
Our Give, Grow, and Gather community outreach subsections will affect thousands of lives.
Our custom design and manufactured robot.
Unique controls allow us to have a consistent autonomous and teleop.
We strive to embody the spirit of gracious professionalism, as well as transition from a successful FTC team to college-level engineers.
And we have done all of this to earn the privilege to be on the first banner. Thank you so much for your time. Do you guys have any questions for our team?
A lot more than we have time for.
All right, I have one question. It's a great robot. What's the one part of the robot that you're most proud of?
One thing that I've seen go through a lot of iterations is that we had a lot of trouble at the beginning getting the arm to be able to control, and it was slipping, the gears were slipping. So why we actually did this is we first started, we're like, okay, well, our first shaft was slipping, so we switched to a hex shaft, and then even these gears were slipping because they were really small. So then we went and found gears that fit this half-inch shaft, and then that's why we have these pillow blocks here to be able to hold the extra shaft on the end. So that's been one thing that has gone through a lot of iterations, and I'm really proud that the drivers have a really good control over the robot, and it's made our match go really well now.
Thank you.
Follow-up question to the gear motor change that you made. Did you guys use math to try and predict what power you needed to lift the mass of the robot ahead of time, or did you do more trial and error, swapping down, stepping up in gearboxes to pick up speed?
Originally, we did the 256-to-1 because we just wanted to make sure that we could lift the robot, but then afterwards we realized how slow it actually was. And we realized that this one would be enough.
Yeah, so we had a lot of trial and error figuring out how we would hang on the lander.
Yeah, we're right at 16 minutes.
Well, thank you very much for the presentation,
Yeah,
and we wish you a lot of luck.
Thank you guys so much.